Levels in the atmosphere of the greenhouse gas methane released accidentally by the oil and gas industry might be up to 60% higher than climate scientists had budgeted for. A new study, combining long-term atmospheric measurements of methane levels with a way of fingerprinting where the gas has come from, has enabled scientists at the University of Colorado to make more accurate predictions of the status quo. Grant Allen is an atmospheric scientist at the University of Manchester and wrote a commentary on the new study for the journal Nature, where it's been published this week. Chris Smith wanted to know all about the findings and the implications.
So this paper talks about the global methane budget and understanding the different components that make up the budget, the amount of methane in the atmosphere, is really important to climate science because methane is the second most important greenhouse gas after carbon dioxide. So science needs to understand how much methane there is in the air and why that methane's there in terms of what sources are putting it into the atmosphere. So there are different sources like landfills, like tropical wetlands or lakes, and there are man-made sources like oil and gas infrastructure, seepage from oil and gas reservoirs, natural seepage. And really this paper is all about understanding the relative role of those two different source types.
How have they gone about doing that?
So the different sources have a different fingerprint, if you will. So in, say, a landfill emission, there might be less carbon-13, that's one of the isotopes of carbon in the methane molecule, compared with the man-made emissions, which tend to be more enriched in this different type of carbon, carbon-13. If you look at the composition of the methane molecules in the atmosphere, you can distill a picture of what source mix there must have been to create the observations that we can record around the world.
And where are they making these measurements? Have they gone to different places or is there just one central measurement location?
Well, we're very lucky to have a global monitoring network that measures methane concentration and occasionally takes samples that can be analysed in the laboratory. So this study uses a very long-term data set, 30 years worth of data from these global monitoring stations all over the planet to look at the trends in time and how the different sources have changed with time by looking at that record.
So if people have already been studying this for 30 years, what does this new study add?
So this new study is the first to combine all of the available knowledge that exists on this carbon-13 composition of methane for the different sources. So up until now, there has been lots of different papers that have sort of characterized the fingerprint for one source or another in one place or another at different times. And this study has used all of that at once and this 30-year record of methane concentration to back out what the relative contributions are, the percentage terms for each source through time over the past 30 years.
And are the results surprising, or do they agree with what we've found previously?
They are surprising. There's a kind of a war going on in the greenhouse gas community at the moment on this very important science. One set of methods, which this study represents, calculates a much larger role for these man-made emission types compared with the natural sources. There's another community that are looking at the data in a very different way, and they calculate a much reduced role for oil and gas infrastructure, for example, and a much heavier role for these natural microbial emissions in landfills and wetlands. The reason that they're so different in these two different approaches is that they both suffer from a lack of data.
And in this present research, what do they suggest about the contention between how much of the methane budget is down to us and how much is down to sources in the environment?
So because they've used this new database and they're able to put a range on the uncertainty, the paper reports that for the natural emissions, they typically account for 55 to 70% of the total methane that's emitted to the atmosphere, and the man-made sources, plus some natural seepage from geological reservoirs, would likely account for between 30 and 45%. So you can see that there's a sort of a 15% range in both of those, but the natural sources still dominate. But what this paper calculates is a much larger role for these man-made emissions compared to previous studies.
And on one hand, is that not good news? Because if that is much bigger as a proportion of the emission, it's still something we can do something about, because it's down to us that gas is being released, so we could potentially try and stop it.
Yes, that's right. Yes, potentially that is something that we can mitigate going forward. So in some ways, because even though it's bad news for that particular industry, as you say, it is something that we control.
That was Grant Allen speaking to Chris Smith about the study by Stefan Schwitzke, published in Nature this week.